So yesterday we talked about circle in general in lesson 1, where we define a circle as the set of all, points equidistant from the center, called the center of, the circle. And here we said we name a circle by, the center. So if you have a circle with center A, so that circle becomes circle A, okay? And we also define chords being, the line segment between two, that have it, their endpoints on the circle. And we said when you represent circle, a chord, you always have to put a bar on top of the, the two alphabet letters you pick. And we also define a radius being the, the distance from the center to the, to any part of the circle, and the diameter being the longest chord which passes through the center. Okay. We also define tangent lines, which are, lines that are outside the circle and only touches the circle at one point. And the point at which the tangent line touches the circle is called a point of tangency. We also define secant as lines that passes through the circle. So that's an extension of the chord. And we also talk about angles, inscribed and central angle. We said the difference is that central angle has its vertex at the center of the circle, whereas the inscribed angle only has its vertex, on the circle. So to form a central angle, you need to add two radii together, and to form an inscribed angle, you need to add two chords together. And we also saw the little definitions of like congruence angle being angle of the same size, and how do you measure, compare two angles? It's just to compare the radii, if they have the same radii or same diameters or same circumference. And we also talked about concentric angles, which are angles that are inside each other with common center. They don't touch, but they have a common center. And we also have, what is it called? Tangent, internally and externally tangent angles, circles. The internally tangent are, circles that are inside each other, but with different center, but touches only at one point. Externally, they're outside each other, and then they touch exactly at one point. So today we're gonna quickly see what we call arcs and their central angles. We already seen central angles yesterday, so we're just gonna talk a bit about it again. And the date is there, the homework is there. So yesterday, my policy right now with Unit 9, as you can see at the back there, Geometry Go Unit 9, 0 missing homework. So as we finish, we're gonna quickly go to the homework and make sure to, solve some parts together, and the rest you have to finish them and then submit before you leave. Please let us help ourselves. This is the last step towards the end of the academic year. Let us do better. For those that have been doing better, never relent. And those that have not been doing better, never give up. There's still always, light at the end of the tunnel. Some people tend to do better at the end, and then when you cumulate it to what you've been doing at the beginning, it might take your grade to something great, okay? So let's quickly go for the notes. Yesterday, as you can recall, these are things, oh, what am I writing here? What is going on here, man? Okay, yesterday we quickly talked about these things here. Radius here, we're gonna name the radii we have here. This is one of them, this is another one, and this is another one. So because radius is start from the center and you end on the circle, so we have T, Q, and it always has a bar on top, T to R. And it doesn't matter, you can change the position, T to R, TQ, and QT are the same, okay? There's no difference between those two components. It's like you moving from Indiana to maybe Chicago. If it's 100 miles, Chicago back to Indiana is also 100 miles. There's no negative in distance, okay? When it comes to distance, there's no negative number. And then the last one is TS, but I'm gonna write ST in order not to confuse ourselves here. So then we're gonna name a diameter. A diameter is just the longest chord that passes through the center. So here I have this chord here, and it passes through the center. So QS becomes the diameter here. And then they said we should name a chord that is not a diameter. So that means we're just gonna name something else. Okay, so a chord that is not the diameter is just gonna be, this is a chord and it's far away from the diameter. Okay, so this is PS. Let me represent the other guys. This is, and then this also represents, and then they should naming a central angle. We have two of them here. We have the first one, which is when you join these two radii together, we have a central angle here because the vertex here is T. So central angle, we have angle RTQ. RTQ and QTR are the same, okay? And we also have another central angle here, which is when you move from R to T, then to S. This angle formed here is also a central angle. So it's gonna be, always if you are putting angle measurement, make sure you put the less than symbol before you start your work. Oliver, did I give you a note? Yeah. Okay, thanks, sir. This is gonna be RTS. And name an inscribed angle. And inscribed angle is an angle, you know, where the vertex is on the circle. So here, if I join this chord, call also the diameter to this chord, I have this angle here, and the vertex is at S. So that's an inscribed angle. So it's gonna be Q, angle first, Q, and then S and P. So the new stuff we want to learn today is about arcs and central angles. So definition of an arc is just, an arc is part of the circumference of a circle. So the circumference of a circle is, you know, the total distance when you move around the circle. In a square, you know, it's called the perimeter, where you say if the square has 4, each side being 4, the perimeter going to be 4 plus 4 plus 4 plus 4, and 4 times 4 plus 4, 4 times, that's going to be 16. So if this is a meter, so the perimeter going to be 16 meter. But in terms of circle, we call it circumference, okay? So an arc is just a part of the circumference, so it differs. So this purple side here is an arc. You can have DB, you can have DE as an arc. We can also have EF as an arc. And we can also have FC as an arc, just part of the circumference. And you know, you can have multiple of them as you want. You can have BD as an arc, okay? Then we're gonna go deep into this by finding the angle measures. So we have 3 of them in general. We have the minor arc, we have the semicircle arc, and then we have the major arc. So the minor arc is less than half the circumference. So which means if you take a circle and you take some, you know, a part of it that is less than the half of it, so that part becomes a minor arc, okay? Like a BC here, in purple here is a minor arc because it's not half of the whole circle, okay? So the minor arc, we're gonna name them. And this is how arc is represented. When you write the alphabet like BC, just make sure you write BC this way. And then you put this symbol, like a cover, okay? To show that it's this, you know, like, you know, you are trying to draw a circle. So BC is an arc. And also we have a D, as you can see, BD is also a small arc. So BD is also a minor arc. We have several of them. We have a DE as a minor arc as well. because BD is not half of the circle. DE is not also half of the circle. This side here is not half of the circle. The green up here, let me change color for it. This BD is not half of the circle, so it's a minor arc. And we also have EB, you know, even having, you know, we have many of them. We also have EB, we have C, you have CB, we have CD is even also a minor arc, CD. Because if you move from C to D, it's not half. For you to have half of this, half means if you take CE, okay? So here you can manipulate your way. CB is a minor arc, CD is a minor arc, but CE is not a minor arc, okay? We also have BD, and then we have BE. BE, if you move from B here till you reaches E, is less than half of this circle. And the other side, we also have this CF. If I take CE, it becomes half of the circle, so it overrides the meaning of minor arc. So at the other side, I have this EF. So you can name as many as you want, okay? So it depends on your intuition. So I'm just gonna stop it there. So I'm by putting these 3 dots to say etc., etc. And another one is what we call semicircle or half circle. Semicircle is just half the circumference, okay? So here, you're gonna see, since we said the diameter will always divide the circle into 2 equal parts. So one part is this, okay, which is AC. And the other part is the green below here, which is AC again. But sometimes instead of writing AC and being confused, it's better you put one letter in between, because this AC, the red one, and the AC here, the green one, might try to confuse you. So the best thing to do is by making sure you include a letter, like if I take CEF, CBE, that means I'm talking about this arc where there's, C is included, a B is included. Instead of CE, I'm just gonna add CB, or sometimes you might even add D to say that you are talking about this. And the other side, the green one, since it's also C to E, it starts at C and ends at E, I might just put a letter in between to show that this is the exact one I'm talking about. Since F belongs to that arc, I'm gonna put F here to show that this is the one I'm talking about. Because both start at C and end at E, the red and the green. But the difference is that B is included in the red and F is included in the one below. So as a mathematician, when I see this, I know which one we're talking about, okay? But if there's no B and F in between, I'll be confused. And the next one is the major arc. The major arc is always more than half the circle. So we have 3 types: the minor, the semi, and the major, okay? Minor, less than half. Semi is always half, and major is more than half, okay? So here, we're gonna name the major ones. So for the major, you need to go beyond 90 degrees, okay? Hey, you need to go beyond half of the circle. So since this is half here, so if I go beyond this place is more than half, okay? Then since I'm talking about the red, I might just say C to F. But if I say CF, CF might mean the green one I left out here. So to be able to say that it's about the red one I'm talking, it's better to make sure to have a little space in between and then put any of these three letters. Either I put B or D or E. So let me put B. To mention, to say that I'm talking about from C to B and B to F, okay? Another major arc, let me try to clean this. We can have many of them as you want, so you just need to, if I move from C to this place, this is bigger than half of the circle, isn't it? Okay, because if I call it here, this is bigger than half of the circle. Then I'm gonna take from C to E, a C to E, but making sure that I'm not talking about this small size I left out by putting maybe C in between. By putting, this is F, I'm sorry. You're moving from F to E by putting maybe C in between to show that I'm talking about the circle that contains this C component, and then I move to E. I start at F, C is included, and I move to E. You can start at F, you can include B. Instead of C, you can write B, you can write D. It depends on you. But once you write something like that, I know what you're talking about. And here you have, you can list many as many as you want. And since an arc is part of the circumference of the circle, so it means it's also going to have its own measure. Since we can measure the circumference of a circle, which is the total distance around it, so it means we can also measure the arcs. So the measure of an arc is equal to the measure of the central angle that intersect the arc. Which means once you draw your arc in blue, this blue path, if it's 45 degree, arc, and the arc too, arc is also measured in degree, okay? Your unit is in degree. If it's 45 degree, that means the angle that is formed down here will definitely be 45 degree, okay? So if I have a big circle this way, and now I decide to have this arc here, so I'm gonna see if the center is here, then I'm gonna trace this, the beginning of the arc and the end of the arc here. If this green part of the circle is 78 degrees, so that means the angle that is formed here is also 78 degrees. Okay. So the measure of an arc is equal to the measure of the central angle that intercepts the arc. The central angle that intercepts means since the arc starts here and ends here, I'm gonna draw a line that goes through the center, also a line that goes through the center, and those two lines are called radii. So we're gonna have some exercises at the back just to illustrate what we've been talking about and then go to the homework. So here, as you can see, the arc here, the measure of arc JK, this arc JK is 21. Since the units here, the angle here is 21, so JK is 21 degree. And then we want to find the measure of JNM. JNM, I'm going to put it in green, is this angle here. And what do you notice? 25 and the JNM are up to 180 degree, then they are supplementary. Okay? Because if I decide to have this, this straight line, this yellow straight line is 180. So to get JNM, I'm going to do 180 minus 21. And 180 minus 21 is 159. So it means this green angle here is 159. And if that green angle is 159, that means the arc that is formed here in front of it is gonna definitely be 159. So JNM is 159. And I want to find KL. KL, arc KL, let me change color. K here to L, this arc, since it has arc symbol, so this arc here. And since this angle is 159, and you know, we have two lines crossing, so the angles that are formed at both sides are gonna be what? Opposite angle, they're gonna be congruent. So this angle here is 159 as well. And if an angle is 159, the arc that is formed through it is also 159. So this arc gonna be 159 as well. So the arc KL gonna be 159. And we are told to find the arc, the measure of the arc JKM. Let me change color so we can all see better. JKM, I wanna move from J, then to K, and then to M. This is big. We all know that this guy here is 21. This is 159, and this 21 and this 21, these two angles are opposite. So this is gonna be 21 as well. So that means this baby angle here gonna be 21. So JKM, which is the whole of this blue line, gonna be 21 plus, it's gonna be JK, arc JK plus arc KL plus arc LM, which means it's gonna be too much colors here. It's gonna be this, which is 21, plus this, which is 159, plus this small one, which is 21. And that gives us 201. So it means the whole of this arc in blue color is 201 degree. Okay. And then I want to also find measure of arc MKL. Which color can I choose? Okay, this M. I want to move from M to K and then to L. This is a major angle, major arc rather, because I want to move from M to K. So if K was not included, how did it mean I was told to find ML? I might be confused to say, oh, maybe it's this. But since they added K, that means I have to go around. Then what should that one be? I moved from this place to J first, which is 159, the green one. So I'm gonna put 159 plus, and then I move from J to K, which is 21, plus I then move from K to L, which is 159. Then adding these three numbers gives me what? Three what? 339? Yeah, 339. So that's gonna be 3. Or another way, since you know that the total circle, you know, the total angle around the circle is 360, and then you know you're gonna remove 360, 21. Since this opening is 21, this baby small opening here, this opening here is 21. So you're gonna do 360 minus 21, which is also 339. So you have your different ways to getting your answers, okay? You don't have to pass through my own strategy. It's like when you go to the mall, we have various entrances, the south, the north, the west, the east. So whatever you enter from, the measure, your purpose to get inside and get whatever you want to get and leave. Okay. So we're gonna use the same strategy to solve the next problem here. The measure of angle UXV. U we're gonna move from U to X and then to V. You said? What is it? No, U to X to V, we don't know it yet. But what do you observe here? As you can see here, this line crosses, this is a diameter, this is another diameter. And the arc that is formed here is 72. That means the angle that is formed here is going to be 72. This angle also going to be 72. And the arc that is formed here is going to be 72. You can see now? So it means UXV going to be 72. And then the measure of arc ST. What will ST be? This is ST. We all know that this red line here is a diameter, so it cuts the circle into two, half. Okay. So and then the circumference of the diameter is always 180, because this red line represents 180 degree, and then the angle that is formed at the green circle here going to be the same angle of the angle that is formed at the arc here going to be the same angle here. So you're going to do 180 minus 87 minus 72, because the red angle 72 plus the angle that is 82 plus the green angle will be 180, because they're going to be on a straight line. Then if you do your calculation very well, this gives us 21. So it means that the green angle is 21. The green arc and angle are both 21. Then I want to find arc WV. WV is this arc here. And I know this arc and the angle formed down here are going to be the same. And I know 72 plus the 72 plus the purple arc here will add up to 180. So I'm going to do 180 minus 72. And then when I do 180 minus 72, I said this guy is 21 here. Okay. 180 minus 72 gives me 108. I like using same color so as to see what's going on. So here, this is going to be 108. So it means 72 plus 108, which is 180. Then arc TW, then T to W. Which color can I use? Okay, T, you're going to move, this guy was 21 at the beginning here. This angle is 21, so this arc is 21. This angle is 108, so this arc is 108. So we need to take, you need to take attention of such. And this guy, since the angle is 81, the arc is 87. Then we are being asked to find TW. You want to move from T down to W. That will be the sum of these two angles, okay? That will be 21 plus 72, and which is 93, if I'm not lying. So this is 93. Because from T to W, you have to move from, first of all, from T to S, which is 21, and then S to W, which is 72. Then TVW. So this time around, you see the difference now. They said TVW. So it means the other arc, which is a major one. So which color can I use? This black. T, then to V, and then to W. So which is going to be what? T to U, which is 87, plus U to V, 72, plus V to W, which is 108. And what do I do? What does that give us? 267. Beautiful. It's in degree every time, please. This is long, man. So a simple mistake will just make you fail everything. Imagine I've gotten 71 at the beginning here, so it means all these results are gonna be wrong. So you need to pay attention very well. So here, what we know here is we have a lot of information here. Here, this angle is right, so right angle is 90. So the arc here gonna also be 90. This arc here is I like different color, 34. So the angle here is 34. And it says arc CD. CD, I've already done it without, sometimes it's better to, when you see your graph or the shape and the information, make sure you work on it before going to the question. So CD, without even knowing that, I will be asked CD. So CD is 90. As you can see, the arc here, CD 90. FD. And another thing is that since CD is 90 and this is a diameter, so it means the other angle gonna be right as well. So this angle gonna be 90 as well. And if it's 90, it means this arc that is formed around it gonna also be 90. Okay. And then the next question says FD. FD. So I'm gonna move from F to D. Sometimes when they give you arc and then if it's 2 letters, most of the time it's always minor arc. Okay. When it's 3 letters, it means you have to take consideration of some things to show maybe something that is a major arc. So here, C to D gonna be C to E, which is 34, plus E to D, which is 90. And 34 plus 90 give us what? 124. So it means this one is 124, the yellow one here. Sorry for my handwriting, quite bad. And then DCF. Okay, so you see right now, DCF, D to C and then to F. That talks about the major arc, okay? So DCF, we know DC to be 90. We don't know CG, and we don't know GF. So what are we gonna do? Okay, so thank you, Tyler. So here Tyler said, since this is a diagonal, a diameter rather, so this angle also gonna be right. So they're gonna be 90. So this angle as well gonna be 90. And then to get this one, you're gonna do, and these two angles here, which color can I use, man? Okay, these two angles here gonna be complementary. Okay, because this guy is already 90, so this small angle here gonna be just 90 minus 34, which is what? What is 90 minus 34? 90 minus 34, please. 56. So it means this angle is 56 and this arc here is 56. So it's gonna be 90 plus 90 plus 56. 90 plus 90 plus 56. So what does that give us? 90 plus 90, 180, 180 plus 56, class. That's 4, 4, 2, okay. 2, 2. Did I get it? Oh, this is 6, 6, okay. I did a minus. That's 6, this is plus, so this is 6, This is 236. Good. So this is 236. Or another way to get DCF is or. I'm gonna put or. It's just to the total circle is 360. You could have done 360 minus this yellow arc. Okay, isn't it? So if you take this yellow arc away from this, the 360, you're gonna have 236, isn't it? Yeah, 360 minus 124 is 236. Because the total circle here, the total angle around the circle is 360. And then we have one part here that is 124. And we want to know the other part, this part. So you just to do the total minus the part we already know. And then lastly, GDF. Which color can we use? We have already exhausted. Okay, the black is the GDF. I want to move from G. So GDF, I didn't mean I go this way, GD, and then F is somewhere here. So that's wrong. So I need to go other way around. So I want to move from G to D and then to F. What would that give me? That would be G to C, which is 90. That means this distance here, 90 plus this distance 90 plus this distance 90 plus this distance 34. So it's going to be 90 plus 90 plus 90 plus 34. And then if I calculate 90 plus 90 plus 90, 270, 270 plus 34, that's 304. Or another way to calculate that, since the total circle is 360, I'm going to just do 360 minus this GF, this small piece here. Okay, 360 minus this piece, that will be 360 minus 56, yeah, 56. And when you do 360 minus 50, that gives you 304 as well, without stress. The last thing, this thing is too long, we won't be able to touch the homework, so we are sorry for that. And we hope you're gonna do it yourself back home. Here, this is 19, this arc has to be 19. And then it means this arc is also 19, and then this arc is 19. This is, the whole of this is 90, so P to R gonna be 90 degree. So we also know that this angle here definitely gonna also be 90. And then PQ, P to Q gonna be 90 minus 19. Let me change its initial color, 90 minus 19. Because PR is 90, and then we want to find one P. So PQ plus QR gonna be 90. So to get PQ, you're gonna do 90 minus 19, which gives us 71. So it means this angle is 71. So 71 gonna represent this angle here. And then SR, we wanna move from S to R. SR is the whole of this. So since the whole of this angle S to Q is 180, because this is a diameter, then 180 minus 19, which is 161. So it means this angle is 161 and the angle here is 161. And QRT, I want to move from Q to R, then to T. That will be 19 plus 161 plus 19. And that gives me 199. PSR I want to do P to R, S to R, P to S, then to R. P to T is 90, T to S is 19, and S to R is 161. So adding these three numbers, I have 270. And then lastly, I want to find a PS. PS is from P here to S here. That'll be 90 plus the blue, is it blue? Anyway, blue 90, then plus the red 19. 90 plus 19, which give me 109. It's quite a long process. So classmates, make sure if you go to the homework, you do something great. Very, really great there. So as you can see here, AB here represent, the red one represents, the red represents a minor, and then the blue represents what? Which are the circle in name in purple? Okay, AB, the red represent a minor, and then the blue represent a major, okay? And here, AD, ADB. Since D is part, so that means we are talking about the blue one, okay? So the second one here is major arc, whereas the first one here is a minor arc, because inside minor, they don't put mostly the third letter, okay? They only put 2 letters. And here, find the measure of the arc listed below, UV. U to V, if we check very well here. Oh, let me stop the recording.